Hi, I'm Al Broberg of the Hull Loan System, and the purpose of this video is to walk you through the appraisal process that we use here so that you get a better understanding of what the process is and hopefully an increased comfort level with it. And also for those of you who are from out of state, to give you an opportunity to actually see and in effect to meet the person that you'd be doing business with. So we're going to use as our example today this, what appears to be a diamond engagement ring with a round brilliant cut diamond. It could have been sent to us from an out-of-state customer, or it could have been tendered in person here by a customer in our office. And the first thing we want to know is this really a diamond? Okay, so we're going to do 4 tests on this to satisfy ourselves that what we have here is really diamond. Okay, and the first is a microscopic examination, and we're going to look at it under the scope. And what we're really looking for, we're looking for a couple of things here, but the first thing we're looking for is to see if we see any double refraction. I'm going to look through not the table, but through the crown facets. And I'm going to be looking at the pavilion or bottom facet edges to see if I see any doubling up of them. Because if I see a doubling up of those facet edges, I know I've got moissanite rather than diamond. Moissanite is doubly refractive, which means it splits the light into 2 different rays. Diamond is singly refractive. It does not. So if I see a doubling up of those facet edges, I know I've got moissanite. I'm also going to be looking for lasering, and I'm going to be looking for any indication that the stone might be fracture filled. Now, I've actually looked at this stone before, so I do not see any lasering. I don't see the double refraction, and I don't see any indication of fracture filling either. So next thing we're going to do is we're going to test it on our thermal tester. Diamond has a relatively unique thermal conductivity. If I get a positive thermal test, I know I've got either diamond or moissanite. I know it's not a cubic zirconia. I know it's not any of the clear sapphires that are used as diamond simulants or any of the other materials that are used as diamond simulants. So what we do is we just apply the probe to the top of the diamond. We look at the gauge. The little beep just means the probe touched metal. And I get a nice strong reading on the gauge indicating that it reads as diamond, but since diamond and moissanite have the same thermal conductivity, what I know now is that I've got either diamond or moissanite. Okay, so then we're going to turn on the moissanite tester. If I get the sound and light show here, it means I've got diamond rather than moissanite. So that's what I've got. Okay, we're just going to do, we're positive now we've got diamond. We're going to do one other test, and that is for magnetism. Diamonds found in nature are almost never magnetic. Diamonds grown in a laboratory frequently are. And so what this is a very strong magnet, and we're just seeing if we get any sense of magnetic attraction. I do not, so I think I've got a natural diamond here. Now that we know that, what we want to know is, what's the carat weight of this? Because that's going to affect its value to a very large extent. Most people do not want us to unmount the diamond and weigh it, which would give us the most certain knowledge of its carat weight. So we're going to take measurements and we're going to put it into a formula. And we need to know its diameter and its depth primarily here. So we put the millimeter gauge on, and we've got 6.18 in one direction and get the calipers on the gauge. You can watch as little or as much of this video as you want to until you've got the comfort level you're happy with. It's a thin girdle, so I'm having trouble getting, a little bit of trouble getting the calipers of the millimeter gauge on there. And 6.18 to 6.1. Now, that's the range of our diameters. The next thing I need to know is what the depth is, but the way this stone and a lot of stones are mounted doesn't give me the opportunity to put the calipers of the millimeter gauge on the bottom of the stone. So in those situations, what I need to do is put it under the scope and use what's called a table gauge. There's a little millimeter ruler on the side of this, and I just hold that up to the side of the diamond, and it gives me a reasonably good estimate of its carat weight, or I mean of its depth is what I meant to say. And I've got what looks to be about 4 millimeters deep. The other thing which affects the carat weight is the thickness of the girdle. The girdle is a flat disc which separates the crown from the pavilion. If it's thick, we need to add an adjustment factor. This is not, so there's no adjustment factor required to estimate the carat weight here. So we need an average diameter, which would be 6.14 squared times the depth, which is 4 millimeters, times 0.0061 is the formula for round diamonds. And the estimated carat weight using that formula of this diamond is 0.92, just under a carat. All right, so now we know the carat weight. Now we want to know both the clarity and the color grades. And that gives us the basic information then. We need to calculate a loan value. And we grade it for clarity by examining it under the microscope. And I've looked at this stone previously. There's just a couple of minor pinpoints deep in the stone, and I would give this a clarity grade of VS2 on the clarity scale of the Gemological Institute of America. And then what we want to know is the color grade. And the best way to color grade a diamond would be to have it loose and to put it table down in a little grading tray with the master color grading diamonds. But I really can't do that when it's mounted, so what I do is I hold it up under a grading lamp like this, and I compare it to my master color grading stones. And I always start with my lowest color grade master stone, which is a K colored stone. I start where I can see the most color and work my way up. And the K master stone, I see quite a bit more yellowish brown than I do in the stone that we're grading here, so it's better than a K. My next master stone is an I. So that's quite a bit closer, but the stone I'm grading is still a better color than the I. And my next master color stone is an H. And it's a G, I'm sorry. And that's better than the stone I'm grading. So I'm going to give this stone a color grade of H. Now the other thing that might affect the value of the stone is the cut characteristics. But this has got, if it had a very big table or if it was excessively deep, we might take points off of its loan value. But this stone is a reasonably well cut stone within normal accepted parameters. So what we do now is we go to the Rappaport Diamond Report, which is an industry price sheet, the most commonly used industry price sheet. We look for the matrices on round diamonds, and for those that are in the 0.9 to 0.99 carat range, a VS2H gives us a price of $5,800 per carat. times 0.92 times 40% is the loan value. And the reason for that is that 15% of the loans that I make go south on me. And the way we recover what we've loaned out is obviously to sell the collateral. And the people that will buy it the quickest and the most easily from us are the retailers. Or the quickest way to recover what we've loaned out is to sell it at auction. And usually, but not always, we can sell it for about 50% at auction. So we set the loan values for most stones like this at 40%. And when we do that on this loan, or on this diamond I mean, we get a loan value of $2,135. So that's the appraisal process that we use here at the Hull Loan System. If you have any questions, please feel free to call us at 612-333-6726. You can email me at al@hullloansystem.com. I encourage you to check out hullloansystem.com and to follow our blog there. Thank you much.